Hello, this is Minyoung Park, a master student at Dongguk University, and today I will review the paper titled Sentiment Analysis and Emotion Recognition in Social Media, a Comprehensive Survey. The presentation is organized following the same structure as the paper. For the bibliographic information, the objective of this study is to systematically organize and analyze research on sentiment analysis and emotion recognition in social media environments. The authors collected 50 prior studies related to sentiment analysis and classified them into deep learning, machine learning, lexicon-based, hybrid, and dependency relation-based approaches and conducted both qualitative and quantitative analysis based on datasets, evaluation metrics, and tool used. For the introduction, sentiment analysis has become increasingly important as social media provides large-scale user opinion data in the form of text, speech, and images. Such data are widely used in corporate decision-making, political analysis, and service improvement. In particular, sentiment analysis plays a key role in robotic agents and dialogue systems by enabling real-time understanding of user emotions and improving user experience. However, traditional sentiment analysis mainly relies on coarse-grained document or sentence-level approaches, which limits the ability to capture complex opinions on specific aspects such as price, quality, and design. Moreover, social media texts are short and unstructured, often including slang, typos, and cultural difference, which reduce classification accuracy. To address these challenges, machine learning and deep learning based methods have been increasingly adopted. While these approaches improve performance, they require large scale data and complex model structures. Consequently, advanced computational paradigms that support parallel processing and probabilistic inference have attracted attention, offering more context-aware sentiment analysis. The study aims to systemically review sentiment analysis research, compare classification methods, and identify existing limitations and research gaps. So this section presents the general outline with steps. In the data pre-processing stage, sentiment analysis targets data such as social media, news articles, and product reviews, which contain significant noise. Therefore, removing stop words and redundant data is important to facilitate post-processing and improve accuracy. Data augmentation refers to techniques that increase the amount of training data by applying various transformations to existing data, which helps prevent overfitting and improve model generalization. In feature extraction and selection, relevant features are identified and selected from text data, such as synthetic features, words, and hashtags. This process reduces feature space dimensionality, removes irrelevant features, and improves learning accuracy. In sentiment analysis and classification, the goal is to identify positive, negative, or neutral sentiment expressed in text. This is challenging because sentiment varies depending on context, and some words share similar meanings. This figure shows the categorization of sentiment analysis approaches based on the literature review, including deep learning-based methods, machine learning-based method, lexicon-based method, hybrid method, and dependency relation-based method. This is the literature review. Deep learning-based sentiment analysis demonstrates strong contextual understanding, but it suffers from high computational cost, large data dependency, and difficulty in handling complex or multi-aspect sentiments. Models such as sentiment-based GCN, LSTM, and transformer-based approaches improve sentiment dependency modeling and target awareness, yet their scalability and inference efficiency remain limited. Attention-based bi-LSTM model and enhanced context representation, but struggle with complex sentiment expressions. In contrast, machine learning-based methods provide better interpretability and simpler implementation. However, their reliance on feature engineering and limited contextual modeling restrict performance on large-scale, unstructured social media data. Aspect based on traditional classifier approaches work well for small, simple datasets, but show limited generalization, while ensemble models elevate data imbalance without fully addressing scalability issues. Lexicon-based sentiment analysis excels in simplicity and interpretability, but it fails to sufficiently reflect context, scarcity, and domain-specific expressions. And approaches based on automatic lexicon construction or pattern matching are sensitive to lexicon quality and have limited multilingual scalability. Dependency-based methods effectively capture grammatical structure and semantic flow, but prediction stability decreases for complex sentences, and high computational complexity and memory requirements limit real-world applicability. Finally, hybrid approaches compensate for the limitations of individual techniques and achieve improved performance, but increased model complexity, overfitting risk, and computational cost management remain key challenges. This section presents the identified research gaps. Existing sentiment analysis approaches exhibit clear limitations. Lexicon-based methods lack extensibility and fail to capture the relationship between sentiment, polarity, and emotion. Dependency-based methods struggle with complex or figurative expressions, as apart from overfitting and poor generalization due to high-dimensional features. Deep learning-based methods show limited multilingual and multi-domain generalization, impose high computational costs, and insufficiently address real-world or real-time applications. Machine learning-based methods independently handle class imbalance and rarely integrate transfer learning or transformer-based approaches. To address these gaps, this study systematically compares and categorizes deep learning, machine learning, lexicon-based, dependence-based, and hybrid methods, and analyze tools, datasets, and evaluation metrics to identify overall research trends. In the evaluation regarding approaches, a pie chart shows sentiment analysis that is conducted using various methodologies, confirming that deep learning and machine learning approaches dominate. In terms of tools used for sentiment analysis and classification, a clear concentration is observed. Python is the most widely used tool due to its rich libraries, ease of use, and scalability, while other tools such as R and Java are also used to lesser extent. Regarding the evaluation by year of publication, most studies were published between 2018 and 2019, marking a major transition from traditional machine learning to deep learning based application oriented sentiment analysis. Commonly used data set includes social media, customer reviews, and news articles, reflecting a shift from static data to dynamic real-time data for capturing evolving user opinions and market trends. Regarding evaluation metrics, there is a strong tendency toward accuracy-centered evaluation, and in terms of metric values, many studies reported accuracy levels exceeding 80%. So this is the conclusion. The survey reviewed 50 studies and classified sentiment analysis method into deep learning, machine learning, lexicon-based, hybrid, and dependency-based approaches, comparing their strengths and limitations. It highlighted gaps such as overpassing and accuracy, insufficient handling of data imbalance, irony and contextual expressions, and limited consideration of emotional intensity. Future research should focus on context-aware and integrated sentiment emotion models to better capture complex emotions and real-world social media. So this is the end of the presentation. Thank you for your attention.